Hi, this is Alex from devstories.eu. CircuitPython, Episode 1 of 7. If you come from the world of traditional embedded systems, setting up a toolchain usually takes longer than writing the first program. You spend hours fighting with compilers, device drivers, and dedicated flashing utilities just to test a single line of logic. The CircuitPy drive bypasses all of that entirely. Embedded developers often instinctively look for a flash tool, a compiler, or a specific integrated development environment when starting a new project. With CircuitPython, you do not need them. There is no compile step. The operating system file system handles the deployment process. When you plug a CircuitPython-compatible microcontroller into your computer using a USB cable, the board presents itself to your operating system as a standard USB mass storage device. This removable drive mounts automatically and is named CircuitPy. To your computer, whether you use Windows, macOS, or Linux, it looks exactly like a standard thumb drive. You can open it in your File Explorer, view the contents, and modify them. Inside this drive, the most important file is a text file typically named code.py. This file acts as the entry point for your application. You can open it in any standard text editor. It does not require a specialized application. A basic text editor works perfectly. When you write a simple program, perhaps a loop that prints text or interacts with the board, and hit Save, the deployment cycle begins automatically. Here is the key insight. You do not need to click a build button or run a command line utility to push the code to the hardware. The moment you save the file, the microcontroller detects the file system activity over the USB connection. This behavior is driven by a mechanism called auto-reload. CircuitPython actively monitors the state of the USB mass storage connection. When you initiate a save operation in your text editor, the computer writes data to the CircuitPy drive. CircuitPython waits until the file writing is complete. Once the file writing finishes, the auto-reload system triggers a soft reboot of the microcontroller. This soft reboot is extremely fast. It interrupts whatever the microcontroller was currently doing, safely tears down the current state, and completely clears the memory. Then, it immediately parses and executes the newly saved code.py file from the top. The auto-reload mechanism creates a very tight iteration loop. You edit the code, save the file, and watch the hardware respond in less than a second. If there's a syntax error in your newly saved code, the execution halts safely. You can view the error output over a serial connection. You fix the typo, save the file again, and the board instantly reboots to try the updated code. The CircuitPy drive is also the mechanism for managing dependencies. If your project requires external helper code for specific hardware, you do not use a command line package manager. You simply drag and drop the necessary library files directly into a designated folder named lib on the CircuitPy drive. The auto-reload system tracks changes in this directory as well. Before we wrap up, if you enjoy these technical episodes and want to support the show, you can search for devstories.eu on Patreon. The fundamental shift here is that the file system itself acts as the deployment pipeline, turning any machine with a basic text editor and a USB port into a fully capable embedded development workstation without installing a single driver. That's all for this one. Thanks for listening, and keep building.